What's up? It's time for another review. This time it is of this USB 3.0 power meter, I guess. It's a volts, an amp, and power meter that also measures capacity that's gone through it. So it's made by the company Drok. They sent me a message on YouTube and said, hey, if we gave you one of these, would you review it for us? And I said, sure, why not? And I've been doing stuff related to this. I have a DC load project I've been working on for testing a bunch of big-sized, really big-sized USB power banks for use with my. I have the new MacBook, the one that has USB-C. And the interesting thing about that laptop is that you can charge it. You can you can plug devices into it that'll use power from the port, or you can charge the laptop through the port in the other direction. And the interesting thing about that is that you could plug the laptop into a power bank and charge it, and it's actually a full desktop class laptop that runs a full desktop OS. And I have Windows 10 and OS X that comes on there, and for dual boot. And it's a great little laptop that a lot of people love to hate, but that seems to be all Apple products. People love it or hate it. And so yeah, I bought a bunch of those and wanted a way to test the actual capacity of them, and then a way to be able to test the maximum amount of current they're able to deliver. And so I was working on a DC load project, and this isn't a load, but this is kind of a pass-through device that basically takes measurements and shouldn't really affect whatever you have plugged. And it's a plug-through device. One end is USB A male, one end is USB A female. And so I checked on Amazon to see. They just mailed it to me, and until I received it, I hadn't actually looked the price up. So just before starting this video, I looked up the price. You can get this exact one. This says USB 3.0 pass-through. So you could have a device like an external hard drive that uses USB 3 for its faster throughput, and this wouldn't bottleneck it. And it's, oh no, I already forgot. I think it's $43 or $45 on Amazon, and I think that's Amazon's where they sell most of their stuff. Now they 43 might sound like a lot for what it does. It's actually a really neat device, and I think if you needed the USB pass-through speed of USB 3.0, I think that it would totally be worth the $40-some. If you don't need the USB 3, you're literally just testing things related to charging, like a USB power bank, for example, and you're not actually passing data through the device. I recommend that you get the USB 2.0 version they have, and it is only $14 and I think 53 cents. Yeah, it's like basically a third of the cost of this one, and does everything it does. Well, this has a couple extra features that one doesn't. This one allows you to rotate the screens, so if the device on your bench or wherever you have it mounted or you're using it is this way, there's an option to flip the screen built into the UI. And this one also has 10 data points that'll let you store on the onboard memory, so even if you power it off, it remembers. But I imagine that's something that most people probably wouldn't use, because you'd be using this on your workbench or somewhere where you have access to pen and paper or a spreadsheet or wherever you're going to write your data down. But that being said, it does have 10 data points you can store the memory to, and it does USB 3.0 pass-through. So you can actually transfer USB 3.0 data through it, and it shouldn't affect your throughput. It comes in this neat little tin, which could be handy for some other projects, and it's got a little window on it, so if you wanted to put like a little headphone amp or something in here, it'd be kind of cool to be able to see your components. And actually here, and like I said, if I ever get provided something to review, I'll let you know. And I think I could have sworn there's even a law in the US that says that if you're a journalist and you review something but you were given the product that you're reviewing, that you have to disclose it. I know it's at least fact with auto companies, but I don't know if it applies to this kind of stuff. But I will tell you, there's complete transparency. You have no reason to lie. So here's the little business card they included in the packaging. But yeah, they sent me this free of charge, and I get to keep it. Only stipulation is that I review it. So it comes in this tin, and it actually comes with a really nice manual. It's actually on really good like cardstock. It's fold out, but super clear. It's obvious, you can tell the English isn't perfect, so it's not like they just ran it through a translator. It's actually pretty decent. You could understand it. There's sometimes you'll get manuals that are converted from Chinese to English, and they're really hard to read, but this one is actually pretty decent. You can definitely tell that it's been translated from Chinese to English, but I didn't have any problems understanding any of it. And so here are the basic specs if you would like to pause it. But it's got a pretty wide voltage range, which is good because if you're messing around with something, you don't want to accidentally fry the unit. It's got some pretty wide tolerances. It'll measure current up to 3 amps, up to 39 watts, and then here's the accumulation for capacity. Looks like basically 100,000 milliamp hour, or is that the same? Yeah, 100,000 watt hour. Oh, milliwatt hours, or it'll show it as watt hours. I don't think the milliamp hour ever changes to just amp hour. And here's the basic accuracy. So it's 0.2% plus 1 digit, which is pretty good. And current measurement, and that right there is actually better than a lot of multimeters are. So that's really not that terrible. That's actually pretty decent. And we'll compare it against my bench multimeter to see how accurate it really is. And then here's the current measurement accuracy, which is 0.8% plus 3 digits, which again, there are a lot of multimeters that are not even that good. So that's pretty decent, assuming that we can believe this. Update rate's 2 times a second, which is okay. Idle discharge 10 milliamps, and we will test that because obviously the unit itself draws power, and if you're measuring and you want to be super accurate, you'll need to take this into account because I imagine the unit only measures the current that goes across this shunt, and I imagine this runs in parallel with the microcontroller and the screen, and all the electronics in here would run parallel with whatever your load is, so it wouldn't count this current with the actual current going across their shunt resistor inside. So it's super light, not even worth mentioning the weight. I mean, this thing weighs nothing. Even in the metal tin, it weighs nothing. And it's super tiny. And this one will do USB 3.0, but it's the $45 model, I think, or somewhere around $45. Like I'm probably a few dollars off. And the screen is OLED, so it's super sharp. And I think it comes in white. The background's always black, but it comes in white or blue. I think this one is the white text, which I like better. I think the white looks sharp. And then the instructions, super clear, as you can see. The English is actually pretty good. It's a full color manual. There's little diagrams or screenshots of what the screen will show. Shows you how to do mode selection. You can do zero calibration, or you can zero it out because it says, after a while components will age and temperature varies, so it shows you that you can actually zero the unit out, which is pretty cool. And then it shows you over and under voltage reminder. It shows a little arrow that blinks whenever you go outside the threshold, which is 5.3 volts on the high end, 4.7 volts on the low end. And we can test that also, and I'll show you that the little thing comes up and starts blinking. Let's see. So on the display, up in the top right corner, it's circled right here, that's the data set. It's 0 through 9, so you have 10 memory slots where it basically stores the data. And whichever one is currently on the screen is the one that it's actually logging the data to. And really the only thing it logs is just the capacity, the total amount of capacity that has flown through the device. And right there, just to the right of the voltage, just the little arrow right there, that's what'll blink to show you that you're outside of the voltage range, which I think is actually, I would imagine it's close to what USB's actual spec is, or maybe it's exactly what USB spec is for voltage range. And this is just saying that it stores up to 9 data points worth of capacity, and then it shows you how to clear it, and I'll show you the functionality of all this. I've already read the manual, and we'll go through and I can show you how you clear it and go through the paces. It shows you how to rotate the screen, and then it shows you how to shut the screen off to preserve current. I imagine the screen's probably half the current that it draws, so. But yeah, that's it. It's a super good little manual. I really can't complain. Normally stuff comes from China. They have some pretty poor manuals, but this is a pretty good manual. I don't really have any complaints. It comes with a little lanyard. It's kind of a girly sky blue color, but it's cool that they included one. I don't think I'll ever use it, but here's the unit itself. So it just looks, it's basically the size of a flash drive. So for comparison, here's a Micro Center flash drive. I'm sure if you live near Micro Center, you're familiar with these. And it has the female end here, and then it has the male end here. And it's blue, so you can tell it's USB 3. And the screen's on this side, and you can rotate it to where you can view it from either way. And then there's a sticker on the back, and then basically right here in the center, you can probably hear that, it's a tactile button. It's basically a yellow spot that says key. It's a button. And that's it. It's pretty basic. So let me think of a good way. I don't know if I have any USB A to A cable. Well, actually, I might. Hold on. Okay, so unfortunately, this ridiculously long, I think it's like a 6-foot USB extension cables. Best thing I have. I guess I could have gotten out a battery bank to hook this up to, but anyway, this should work. So plug it into here. The other end is just plugged into my, I think it's an Anchor 6-port. I think it's like a 40 watt. Is it 40 watt? It's pretty high wattage. I don't remember what it is, but oh, I guess I could do the screen reverse. But so when you power it up, it shows the capacity part basically blinking, showing that this is actually from a previous run. So if you double tap the back button here really quickly, it goes into the little memory viewing screen where it shows you the measured capacity of each memory slot. And so if you push and hold the button on the one that you want to wipe, it clears it. There you go. So now you double tap quickly again to go back. There's the old main screen. So what we're going to do some testing with is this. So, where'd I get this from? Oh, Fried Circuits. Okay, this is Lamore Fried. This would be Adafruit. So you'd be able to get this on Adafruit. Glad I had that on the silk screen. It's basically a USB testing thing. It would be more handy to me if it were USB A on both ends. This end is micro, but I mean, it works. I just think that if they made a new version with basically pass-through A like this has, it would be more handy. Either way, I just got a micro cable, and so what we'll do is plug it into this end. This whole mess of cables here. And then I have my bench power supply. It's the Agilent 34461A. Powered on, and I'm going to basically use it to measure the voltage, and then we'll compare what this unit reads versus what the bench meter reads. Now, USB cables, I don't know if you've seen how tiny the wires are inside the cables. There will be significant voltage drops, especially once you start drawing some current, but it should be close enough to give us a good idea of how accurate this is. So this is reading 5.05 volts, and as you notice, the OLED display is extremely crisp and sharp. I love these displays. They're good for showing on camera. Anyway, 5.05, and then if I can lift this up without running into other crap, 5.05. So voltage-wise, it's definitely bang on, and I have no complaints about that. And obviously, whatever you're going to be measuring with this probably isn't going to be... It's not going to be the kind of deal breaker where it's going to matter if it's off a tiny little bit. But as you can see, this was dead on, so you wouldn't have any worries. But it's not drawing any current, so everything is showing 0, which shows you that it's they designed it well. But the interesting thing is, like I said, it doesn't measure its own current draw, because obviously the unit itself uses power to drive the microcontroller and to drive the display. But that's not a big deal because we can measure it and then find out how much current it does use. And so for doing that, I know. Sorry, there's just a ton of wires and just trying to think of the best way to do this. Okay, so what I'll do, I'm gonna plug this into the power brick thing, and then we'll plug the screen's probably gonna be upside down, isn't it? guess we can, yep, we can test the screen rotate. I think you hold it for 4 seconds. Yep, it reboots, and it actually remembers it too, which is pretty neat. So, I guess I don't really need to keep the bench power supply hooked up to it, just more wires in our way. Here, I'll do this. Okay, so I have my Voltcraft VC890 in milliamp measurement mode, and what this little board lets us do, if you have the jumper on, it just passes the current through, but if you pull the jumper off, basically it allows you to measure current. So we have nothing plugged into the other end of the device, so if we measure any current on here, it'll just be what the unit's drawing. So let's see how much juice she's sucking. So it looks like just about 10.8 milliamps, which is what the instructions said. I think they just said an even 10, but that's pretty close. Now what I'm curious of is what it'll draw if you turn the screen off, because when you're doing a really long test, like if you're doing a big load test or something, or you're any kind of test, obviously you want it to be as accurate as possible, and this unit has the ability to let you turn the screen or the display off, so then you preserve that much current. So obviously I can't do it with these because I'm just manually holding the probes on here, but we'll get some, I'll put a different, should I just use, yeah, I think we're just gonna have to use, just because I don't have the alligator attachments for these. I'll go ahead and order some because so far I'm tickled to death with these ProbeMaster probes, so no reason not to go ahead and get their attachments for their probes, but in the meantime the Agilent will have to do. And the reason I'm using it is because it's already got the thing hooked up to it. So what we'll do, I'll hook these up, and then the current draw should be basically what the Voltcraft read, 10.8, once it settles. And then I will shut the screen off on this, so it's still on, it just won't have the display turned on, and then we'll see what the current draw drops down to. You know what? I'm gonna get some leads for that. Do like a female to male. Okay, that should do the trick. So one end is basically just the 0.1 inch type female, and then the other end is male. This way I can hook it up and it'll be more easy to manipulate. So you saw it spike up at the beginning, but then it drops back down and settles. So now it's saying, yeah, it's kind of climbing back up, but Voltcraft did the same thing. It ended up settling at about 10.8. Now it's showing 10.6. So okay, 10.7-ish, 10.6, somewhere between 10.5 and 10.8. Now I'm gonna hold the button. I think it's 6 full seconds. And then when I let go, the display should shut off. So when the display's off, it makes a little LED blink occasionally, and so you can actually see the current draw going up each time the LED turns on. It's kind of funny. Shows me though that they didn't need to make that bright, but I guess if you're using this outdoors, like for like a little, maybe like if you're testing some solar panels or something, maybe you'd want it to be brighter. But for indoors, I would think that you could probably PWM that, chop it up, and then make the blink a little quicker and save a little more energy. But either way, it's going between 2.4 and 4, so you know, somewhere around the 3 milliamp range is pretty damn good. I mean, that's not a whole lot. I mean, if you do a really long test over a period of a day, that'll add up. But as long as you know the numbers, I mean, all you have to do, it looks like it's on and off for about the same amount of time. So you could just average 3.9.5 with 2.48, and then use that as the current draw whenever the screen's off. And then that way you know how much the unit itself is drawing, and you could actually do the math to add that into the total capacity that this measures of whatever you're testing in the end. So pretty neat little device. The only thing I think left is to go ahead and put a load on it, and then show you that it works for measuring current too, and capacity. So when it's in the screen off mode, all you do is just push the button on the back once, and the screen comes back to life, and then obviously the current draw goes back up too. So first, let's do, I just have this, it's one of these little PCB USB LED light things. Not super handy because it's bright and it's not pointed away from the port. It's perpendicular to the port, which makes it a little annoying, and it's going to be really bright in the camera. We'll just see what happens. So as you can see, it says that putting that load on then drop the voltage down to 4.75 volts, and then it says power is 408 milliwatts, and current is about 87 milliamps. And after being on for a while, we should see this tick over to 1 milliamp hour capacity any second now. As soon as it does, we will switch the setup a little bit, and we'll hook it up to my my bench DC load, and we'll crank it up to, we'll do an amp, 2 amps, and then we'll do 3 amps. Oh, there we go, 1 milliamp hour. So the neat thing about this, it has a little, they put the smarts in here basically to detect what's connected, and then it gives the proper voltages on the data, the 2 data lines. And that's actually how cell phone manufacturers are able to, there's actually a USB spec on it. It tells basically the charger, wait, which way is it? No, it tells the device you have connected to it. I don't remember which direction it goes, but it's basically what USB charging devices use to negotiate the charge rate, the rate of charge. And this has a smarts in it to be able to, they said, I think their instructions said, or their sales pitch on their Amazon page said that it supports up to 98% of all devices. So I would imagine most devices you plug into here will be able to do the fast charge. Because if you have one that doesn't have the proper smarts to do that, they will only do the slow charge, which could be 500 milliamps, maybe an amp, when it could potentially charge at a faster, anywhere from 2.5 to 3 amps fast charge, which does make a pretty big difference. If you're in a hurry and you just need to get a really quick charge in, like you're at an airport, that matters. Now, obviously, you're not going to be using this at an airport. This would be more of a something you have at home on your bench, or maybe you're out in your back patio testing some solar panels or something. Small solar panels, not like household ones, but the small ones you would use to charge USB powered devices with. But yeah, I think it's time to hook it up to the load and see what it does. So we're going to use the extension cable, because we're going to draw the load through this. I'm going to hook the my DC load up to these 2 pins. So take the other end, plug it into my USB charger brick thing, and then we will plug this into here. Oh yeah, and see, this is blinking. It's from the last time it was on. We had the 1 milliamp hour that it already recorded, so to reset it, double tap really quickly, and we push and hold to clear it. And see, this is saying memory slot 0 is what we just cleared, and then we double tap, and then we go back, and now it's zeroed out. Tell you what I need for doing stuff like this on the bench is a USB cable with silicone leads. That'd be nice. I don't know if that's a thing, but it should be. It'd be very handy. Hey, maybe it's an idea for Drok. USB cable with silicone leads. I think people would like that. I guess I guess the Apple charge cables or something similar, but I think theirs are biodegradable, and that's why people complain about them dying after a while, because wherever you grab them with your hand, your oils get on them and it breaks them down. Kind of like how essential oils will break down 3D printed materials like ABS, PLA. I guess those are the two main ones. Okay, so this is on the output end of the little USB meter, so now all I have to do is hook up the loads. So I guess I can just hook these back up. Now, I feel comfortable doing an amp on this, but when I do the 3 amps, we'll do it for a short period of time because I don't want to send 3 amps through these dinky little breadboard cables. I'm going to plug it into my DC load, which my constant current, it's the, what is it? It's the mAH, I don't see a model number, M9812. It's 300 watt, 0 to 150 volt, and it's a pretty good little unit. And if you don't know the history behind it, it looks identical to BK Precision. It's because it's based off of BK Precision. They had some kind of falling out, and some employees left BK, and they stole or they borrowed the designs, and then they improved upon it and they released it. I wouldn't mind supporting BK and getting the original one, but the mAH one actually has a slightly better UI in my opinion. The BK one is just a single 7-segment style LED display, and that's limiting because the mAH one has 2 rows, so it can show what current or power or resistance setting you have it set to, and then on the other line it'll show you what it's actually drawing, as well as the voltage and all that other stuff at the same time. It shows more information on the screen. Other than that, it's pretty much identical. So anyway, that's what I'm using to test this with. Okay, maybe if I do this, we'll be a little closer. Good thing is this is OLED and it's got excellent contrast. Oh, actually, let's lower this. There we go. Alright, so I have the load set to constant current mode. It is currently set to 1 amp, so let's turn it on and see what it does. Nothing? It's hard getting everything in the shot here, especially with these non-flexible cables. Okay, so I had these hooked up to the wrong spot. There's basically a side that is one's for current and one's for voltage. So obviously one's in the circuit and one's measuring across. So yeah, I had it on the current side, which you think would make sense for what we're about to do, but that's actually if you pass through and you have something connected to the other end. This end is obviously open circuit, so using the current side wouldn't do anything. If we use the across side, this will basically be the end point, so electrons will flow in through the load and then back out. So now that I got it hooked up correctly, this should work. So it's reading 5.5 volts or 5.05 volts, everything is zeroed out, and I have the DC load set to 1 amp, and here we go. So you can see 1 amp on the dot. Now the voltage dropped down to 4.31. Now that's probably not the fault of the anchor little power brick I have. It's got plenty of power. It's probably the ridiculous voltage drop over this really long, I think this is like a 6-foot extension. Not to mention we're going through that, and then we're going through another 3-foot cable. So it's a good example though. It shows you when the voltage drops below, was it 4.7, the little down arrow blinks to show you that you're on the low end, you're like below spec. And then if it goes above 5.3, there'll be an up arrow that blinks right there that shows you that you're out of spec. And that is actually pretty dead on with what, that's pretty incredible. It's pretty much dead on what the load's saying. So let's switch it to 2 amps. Let me make sure these aren't, yeah, they're not too hot yet. So current set, 2 amps, enter. Due to the extremely long cable, I think the voltage dropped below the unit's safe operating range, but before we try connecting this directly to the power brick, let's go ahead and just try 2 amps again, just to see what happens. Nope, it browns out. So it's gonna be a little harder to get the camera angle right, but can't do a review of this if I don't test it to its extreme limits. Oh, there we go. I can do that, I think. Oh, look, there we go. That works. Okay. So now we don't have a really long cable, shouldn't have any kind of voltage drop. So, and this should be able to do I mean, this is like a 40-watt unit, so let's give it a shot. 2 amps. Yep, it was the voltage drop causing the unit to brown out. I can't remember, on the spec sheet shows you what the voltage range is for the unit, but anyway, it's drawn right at 2.05 amps, and that is pretty much exactly what my DC load's saying. And voltage, yeah, everything looks awesome. Obviously the voltage on the load is going to show different because it's we're doing constant current mode, so it's going to change the voltage on its end to keep the current right at 2. Okay, so obviously it handled that no problem at all. Let's try 3 volts. Current set 3 amps. Sorry, I said volts, then I meant amps. Okay, 3 amps. This is the maximum the unit says it'll do. And here we go. Yep, so it shows you that the Anchor charging brick is capable of doing 3 amps, as is our little Drok USB power meter thing, so pretty cool. And obviously at 3 amps you can see the milliamp hours actually ticking up almost once a second. So I'm gonna go ahead and shut it off because, yeah, the little leads are starting to get a little bit warm. But yeah, it's a pretty cool little unit. I like it a lot. The $40-some price for the USB 3.0 one, which is what this one is, that's a little on the high end in my opinion. But obviously to be able to pass USB 3.0 data throughput speeds, I'm sure there's a lot of things that they had to throw into there to get compliance or whatever. But if you're doing this kind of stuff, you probably aren't messing with data. You probably just need to test power related stuff. And if that's the case, save yourself the money. Actually, save yourself quite a bit of money. Just get the USB 2.0 version, and it's only $15.53 or something like that, and it's on Amazon. Just search for Drok, D-R-O-K, and you'll find it. I will say though, the $14 model, the USB 3.0 model or 2.0 model, it doesn't do the screen rotation like this one does, or maybe it does. No, I don't think it does. I don't think it does a screen rotate. And the UI looks a hair different, and it doesn't do the data storage on the 10 memory points like this one does. But for most people, that's probably not that big of a deal. I don't think I would ever use the stored memory. So for what it's worth, I hope you enjoyed the review. And yeah, if you think this is handy, go and get on Amazon and check it out. The only other thing I have that's similar to this is this Charge Doctor thing I got a long time ago, and I found it to be not very accurate, and it's not super handy. Now it is USB male pass-through, but yeah, no point in me reviewing it compared to this, which you can get for 14 bucks. I think this even costs more, and it basically really can't do anything to me, anything useful. So yeah, if you're in the market for something like this, I think this would be one of the better choices. I remember seeing something like this on Kickstarter. I don't think this is it. I think Drok is completely independent of them, but there are tons of competitors to this nowadays, and I have not messed with any of them, so I wouldn't be able to tell you if this is better or worse than any of those. But I can tell you that from what I've seen, I can't honestly find any major flaws with it. Now, obviously, it's only got one button on it to keep cost and simplicity down, but fewer the buttons, the harder it is to operate it, but it's really not that bad. If you read instructions, which are pretty decent, English instructions, it's really not that hard to use. So yeah, I think I've rambled on enough. Hope you enjoyed the review, and stick around and there'll probably be more. But I think the next videos hopefully will be the individual multimeter reviews. I really need to get those done. Those are just taking up a ton of space in my lab. So yeah, see you in the next video. Bye.